Hey guys, Mr. Barnes here again, bringing another math video, this one again on trig proofs. So I've written a list of strategies that I kind of tell my students to use, and this is what you want to think about when you're doing a trig proof. If you got any FOIL or distribution, you want to do that first, or look for that first. Same thing with factoring, it's one of those things. Generally, factoring is a great thing to do in a trig proof. Then you really have decisions to make with common denominators and writing terms of sine and cos. So I've got this little thing. These are sometimes interchangeable. Generally, this is going to sort of follow this method. Not always, but this will take care of a lot of things. So this video, I'm going to take you through doing some common denominator stuff. So what I tell my students is always easier to put stuff together, this stuff right here, than it is to take this guy apart and try to replicate two fractions. So it's always together to put stuff together in one fraction as opposed to go the opposite direction. So I'm going to start with the left hand side and I'm going to find a common denominator. So my common denominator for this guy is going to be sine squared theta times cos squared theta. So all I'm going to do is basically multiply this one by cos over cos. So cos squared over cos squared, and this one by sine squared over sine squared. So on top of this guy, I'm going to get cos squared theta, and then plus the sine squared theta. And now that's going to be all over the common denominator of sine squared theta times cos squared theta. So you can see that what I have here on top is actually a Pythagorean identity. So it's 1 over sine squared theta cos squared theta. So remember, sine squared theta plus cos squared theta is equal to 1. That's a Pythagorean identity. So now the next step is to sort of peek over here and see what we need. We need a secant squared over a sine. So I've already got my sine, that's going to stay where it's 2. So the thing we need to remember is that cos theta is equal to 1 over secant. So what I tell my students is that if I have a cos in the denominator, I can bring it to the top and make it secant. If I have a cos in the numerator, I can bring it to the bottom and make it secant. If I have a secant in the denominator, I can bring it to the top and make a cos. Secant in the top, bring it to the bottom and make a cos. So there's lots of different things that I can do in terms of flipping these back and forth between numerator and denominator, change between their reciprocals. So if I take cos squared to the top, I have secant squared theta. Now it's squared because of the squared. And then the sine squared theta. And then again, that's equal to the, actually this is the right hand side. And then that's equal to the left hand side. And we got our proof finished. Alright, so there it is. I know these things are one of those things I say, oh, that looks easy when you're watching someone do it. But you really need to practice it to sort of figure this stuff out. Alright, so here's another one. So let's see. I've got, again, 2 things on this side, and then I've got 1 thing on this side. So the only thing I would suggest, if you look at this guy, this actually, to me, I could start something with this, because this is conjugate. It's got conjugate written all over it. You got sine minus 1, so multiplying by sine plus 1 over sine plus 1 would be a strategy for this side. But this side has common denominator written all over it. So, some people might consider rewriting this first. I think I actually am going to consider rewriting it. Actually, you know what? I'm going to leave it as it is and then change it afterwards. Let's see. So my common denominator is cosecant tan. Well, I might regret this, but we'll see what happens. So I'm going to multiply this guy by tan theta over tan theta. Multiply this one by cosecant theta over cosecant theta. So I don't know if I'll regret it or not. We'll see. So then I get cos theta tan theta minus sine theta cosecant theta all over cosecant theta times tan theta. So I get some simplification right off the bat. So sine times cosecant, that's actually 1. Those are reciprocals of each other. So sine times cosecant, secant times cos, cotangent times tan, those are always 1 when you multiply them. So let's just rewrite. And what I'm going to do is I'm going to start changing some stuff to sine and cos. So that's my 4th strategy there, right? So common denominator, then do the 4th strategy. So tan is sine over cos, so sine theta divided by cos theta. I've got my 1, and then my cosecant is 1 over sine theta, and tan is sine theta over cos theta. So you can see I get these coses to cancel, and on top I'm left with sine theta minus 1. And then on the bottom, my sines cancel, and I get 1 over cos. Now 1 over cos is the same as secant, So I get left with sine theta minus 1 over secant theta, which is equal to the right hand side. So there it is, guys, another proof done. So hopefully you kind of start to get to see, how you do some of these. I'd like to thank you guys for watching. If you like this video, share, subscribe. I'm trying to grow my channel, see if I can help as many students as I can, guys. And I'm trying to improve the quality of my videos as well. So leave me some feedback, send me a message, drop me a note, tell me I suck, whatever you want to do. Thank you very much. See ya.